Now we move the next one, 6. If x is a random variable with the distribution function capital f of x is given by. You see, given is capital f of x. It also have 3 values. Then the question is to find the probability density function. To find probability density function. Symbol is f of x. And also to find the probability value p of 0.3 less than or equal to x and less than or equal to 0.6. So here we using capital F of x. So f of b minus f of a formula. Or we already find the probability density function also. So using any one of the formula. What is the difference between capital F of x and small f of x? One time differentiation of capital F of x is nothing but small letter f of x. So first we write the formula. We know that f of x is nothing but capital letter f dash of x. So the one time differentiation of that one is nothing but f of x. So I don't change the given data. Directly I write f of x. What is the first value capital f of x? 0. The differentiation of 0 is meaningless. So again 0 when x is less than 0. Next one. We differentiate that term. We differentiate that term with respect to x. So of is lies in outside. The differentiation of x square is 2x plus the differentiation of x with respect to x is 1. The interval 0 less than or is equal to x less than 1 is the second value. And you see the third one capital f of x value is 1. The differentiation of 1 is a constant whose value is 0. The value of x is greater than or is equal to 1. That's all. The difference between capital F of x and small f of x is just one time differentiation of a capital f of x is small f of x. Where the small f of x indicates the probability density function. And capital F of x indicates the cumulative distribution function. So we write the formula and directly we write the answer. So it is enough. For understanding we write one term. The probability density function is. No need to write this word. For understanding I write the probability density function is understood. We write this f of x. It meaning that the probability density function. So the first one is answer over. That is to find the probability density function. Now we find the second one. Okay, what is the second subdivision? To find p of 0.3 less than or is equal to x less than or is equal to 0.6. Now we have both small f of x and capital F of x. Both values is your choice. We use either small f of x or capital F of x. I use a small f of x. So the formula is 0.3 to 0.6. I use small f of x. That is a probability density function. 0.3 to 0.6 f of x dx. Sir, I use a capital F of x, sir. So what is the formula? What is the formula? Capital F of 0.6 minus capital F of 0.3. You use any one, we have the both same value. 0.3 to 0.6. In this interval, how to define f of x? 0.3 to 0.6, you see, 0 to 1. In this interval, how to define f of x? 1 by 2 of 2x plus 1 into dx. In this interval, f of x is defined as in this manner. So we write. Now we integrate the term. You see 1 by 2 is a constant. First of all, we will take outside the constant. 1 by 2 I will take outside 0.3 to 0.6. 2x plus 1 into dx. 1 by 2. What is the integrating of 2x? The integrating of 2x is 2x square by 2. Okay, 2 is a constant. The integrating of x is x square by 2 plus 1 into dx. The integrating of dx is x. Then the limits 0.3 to 0.6. 1 by 2. We cancel this 2. Is possible, so I cancel. X square plus x 0.3 to 0.6. 1 by 2. I apply the limit. The upper limit is 0.6. So 0.6 the whole square plus 0.6. 1 by 2 of 0.6 the whole square plus 0.6. Upper limit is over. Minus lower limit. I have some space here. So I write here. Minus of 1 by 2 is common. Minus 1 by 2 of lower limit is 0.3. 0.3 the whole square plus again 0.3. Now I simplify here. So 1 by 2 of 0.6 the whole square is 0.36 plus 0.6. The symbol is minus 1 by 2 of, what is the value of 0.3 the whole square? Is 0.09 plus 0.3. 1 by 2 of, what is the value of 0.36 plus 0.6? Is 0.96. Actually it's 60. 6 is nothing but 60. 60 plus 36, add we get 96. Minus 1 by 2 of 0.09 plus 0.3. That means 0.30. 0.09 is 930. So 0.39. So I will take outside 1 by 2. In both cases 1 by 2 is common, so I will take outside 1 by 2. 0.96 minus 0.39. So 0.96, 0.39. 16 minus 9. 16 minus 9 is 7. We already take one borrow. So 8 is there. 8 minus 3 is 5. So 0.57. 1 by 2 of 0.57. If you know very well, here also we cancel. In second table, 0. 5 is exactly 2 times. Remainder, 1. In 17, second table, 8 times is possible. 8 to 7, 16. Remainder 1. Neighbor is 0. 10 in second table is 5 times. Therefore, P of 0.3 less than or equal to x less than or equal to 0.6. That value is 0.285. We write as it is, or sir, I converted in the second 2 decimal number 0.29 also, because it's more than 5 or 5, 0.29. Suppose we do the problem in capital F of x, the same answer will come. So it's your choice. We using either small f of x or capital F of x. The question is, suppose the amount of milk sold daily in a milk booth is distributed with a minimum of 200 liters and a maximum of 600 liters, a probability density function. Important, the question is involved the probability density function. And f of x value is, one value is a k. Suppose x is lies between 200 to 600 and otherwise is a 0. Otherwise is 0 means less than 200 and more than 600, f of x value is 0. Then there will be a 3 questions. The first one is to find the value of k, the unknown value k. Next, the distribution function. The distribution function is, other name is the cumulative distribution function. In shortcut form we say it is a distribution function also. And third one, the probability that daily sales will fall between 300 liters and 500 liters. All are given in word to convert it in symbol. The third one, the probability that, to find probability, so P of the sales will fall between 300 and 500, between. So 300 to 500, in between, to find the probability value. Now we find one by one. The first one is to find the value of k. You see, it is a probability density function. Suppose f of x is a probability density function, you know one concept. The concept is from minus infinity to plus infinity, f of x dx value should be is equal to 1. So first we use the concept. since f of x is a probability density function, is a given data. Okay, f of x is a probability density function. Therefore, from minus infinity to plus infinity, f of x dx value should be is equal to 1. But the limit should be changes depending upon the given problems. Minus infinity to plus infinity. But you see in the given problem, this f of x is possible only when the value of x is lies between 200 to 600. Therefore, the limit will be changes as 200 to 600 f of x dx. What is the reason to write it this one, sir? Suppose a less than 200 f of x values vanish. More than 600 f of x values vanish. So I leave. So now I write in this interval. In this interval, how to define f of x? The value is just k. So k into dx. Now it will take outside the k because k is a constant. 200 to 600 into dx is equal to 1. The integrating of dx is x. So we will take outside k x, but the limits are 200 up to 600 is equal to 1. Now we apply the limits. K of upper limit is 600 minus lower limit is 200 is equal to 1. So k of 400 is equal to 1. So the value of k is 1 by 400. The value of k is 1 by 400. So the first subdivision is over. Now to find the second subdivision, the distribution function. Is nothing but cumulative distribution function. The other name of a cumulative distribution function is also say just a distribution function. But important, this distribution function to find each and every value of x. First we write the formula, and to find the distribution value of each and every value, we know that. I write the formula. Capital F of x is P of capital X is less than or equal to small x. The given function x is false, a continuous random variable. Therefore, this formula minus infinity to x f of x dx. Important the formula. The distribution function or the cumulative distribution function. Symbol is f of x. And whose formula is, you write any one. For understanding, I write both. Capital F of x is nothing but P of capital X is less than or equal to small x. Always start from minus infinity up to x, up to go this x. Suppose it's 2, we go up to 2, f of x and dx. But here so many cases. X is lies between 200 to 600 only possible. We tell all. Suppose x is less than 200, when x is more than 600, to tell all possible events. So now the first case will be take when x is less than 200. To tell all possible value. So when x is less than 200, we write the formula f of x minus infinity to x f of x dx. So f of x value minus infinity to x, we will take the value of x is less than 200. The value of x is less than 200. Our given problem f of x is possible only when 200 to 600. So less than 200, the f of x value is 0. So 0 into dx, so we leave. So f of x value is 0. To tell all possible value. So first one, f of x value is 0. Now the second one. The first one is over. Now we come in the second one. Suppose when 200 less than or is equal to x is a less than or is equal to 600. That means the value of x is suppose start from 200 up to the 600. Is a 200 to 600 to find the value of f of x. For understanding, I write one timeline. You start from minus infinity up to plus infinity. Now we will take the value of x sliced between 200 to 600. I will take here the value of 200 and here the value of 600. We will take this x value is sliced between in this interval. So is your choice, will be take any one. I will take here x. So now we start from f of x from minus infinity up to x. First of all, I write the formula f of x minus infinity to x f of x dx. Okay. But here assume the value of x is lies in this place. So you start from minus infinity up to x. So we split the single integration become a double integration from minus infinity to 200. Okay, this one. Then this 200 to x is the second case. Okay, now we split in two integral. In the first integral, you see the f of x value is defined as 0. So minus infinity to 200. F of x value is 0 into dx. But in 200 to x, x is lies between 200 to 400, the value is given k. So k into dx. We cancel it. 200 to x. We already find the value of k. The value of k is 1 by 400 into dx. So it will take 1 by 400 outside because it is a constant. Is 200 to x dx. So 1 by 400. The integration of dx is x. Is 200 up to x. Now we substitute the limits. The variable is x. The upper limit is also x. So just x. We replace x by x, we get x. So 1 by 400 of, first we apply the upper limit is x minus the lower limit is 200. So 1 by 400 of x minus 200, or I multiply 1 by 400 inside, I get x by 400 minus 200 by 400. So f of x value is x by 400. I cancel these two zeros. 2 by 4 I get 1 by 2. So second case is also wow. Now we move in third case. Suppose x is lies more than 600. X is greater than 600. To tell all possible value in f of x is important. It's not given, just only one value is given to find the distribution function. But to find each and every value of f of x we find, because capital F of x is a non-decreasing function. The value is increases depending upon all values of x. So first our given value 200 to 600. Then to find extra two value, suppose less than 200 we find one value, more than 600 we find the another value. Now it will take when x is greater than 600. For our understanding, here also first I write the formula. F of x formula is minus infinity to x f of x dx. Now we assume this x is lies more than of 600. No need the interval diagram. For understanding, I write the diagram minus infinity to plus infinity. Here x is possible 200 and 600 only f of x is possible. So first we mark f of x is a possible values. Now we will take the value of x is lies more than 600. So more than 600. Here something is a 0, is a negative value, and it is some positive value. Now we will take the value of x is more than 600. So it should be right hand side of 600. Suppose I will take here the value of x. You don't confuse, so I will use 0. 200, 600. Now we will take the value of x is more than 600. Always capital F of x is start from minus infinity up to x. So you start from always minus infinity up to that one. So this minus infinity to x, only one interval. I split 3 intervals here. Now we write this minus infinity to x. I write first of all minus infinity to 200, 200 to 600 and 600 to x. So capital F of x minus infinity to 200 f of x dx. I split the single integration becomes so many integral. So first integral. Next 200 to 600 f of x dx. Wow. Plus 600 to x f of x dx. Always capital F of x is start from minus infinity up to n to x. So we split 3 interval. You know very well in this interval minus infinity to 200. This interval only f of x is possible. All the remaining interval f of x is given defined as 0. So in this interval our f of x value is 0. So 0 into dx. 200 to 600. In this interval f of x is defined. F of x is defined as a k. But we already find the value of k. The value of k is 1 by 400 into dx plus 600 to x. Suppose x goes more than 600. More than 600 also f of x is defined as 0. So you leave the 0 terms because it is 0. I will take outside 1 by 400. Remaining integral 200 to 600 dx. The integration of dx is x. Limits 200 to 400. So 1 by 400 also. Sorry, 200 to 600. Lower limit 200, upper limit is 600. So first I apply the upper limit 1 by 400 of upper limit 600 minus lower limit is 200. 600 minus 200, you know very well is 400. So 1 by 400 into 400. I cancel this 400s. So the value is just 1. So capital F of x value in this interval is 1. We already write the table, the distribution. So just we enter the values capital F of x. We find there will be 3 values. The first value is 0. When the value of x is less than 200 is the first case. The second case, suppose x value lies between 200 to 600. You see the value of f of x is x by 400 minus 1 by 2. When x is lies between 200 to 400, f of x value is x by 400 minus 1 by 2 is the second case. We write here x by 400 minus 1 by 2. It is possible when 200 less than or is equal to x is less than or is equal to 600. It's the second case is over. Now we come in third case. The third case is when x is greater than 600. When x is greater than 600, we do the process. You see that value is 1. It is possible when x is greater than 600. It's important to find all the value. We already tell capital F of x is a non-decreasing function. You see the value is always increases. It may be the starting value is 0 and the last value is 1. So the second submission is forward to find the distribution function also. Now we move the third one. I write in symbol. Suppose the daily process of the milk is lies between 300 to 500. What is the probability value? To find probability P of the interval is given from 300 to 500. So 300 less than or is equal to x less than or is equal to 500. To write this one 300 up to 500. First we write the formula P of A less than or is equal to x less than or is equal to b. There will be 2 formula. One formula is using integration. The another one is using capital F of. Now we have capital F of x. So suppose a cumulative distribution function is given, then the formula of this probability is capital letter F of last value B minus capital F of the first value minus F of A. Therefore, P of 300 less than or is equal to X less than or is equal to 500. So the value is F of 500 minus F of 300. Now we find the value of F of 500. You see, X value is 500. Suppose the value of X lies in this interval 200 to 600. Capital F of X defined as X by 400 minus 1 by 2. So F of 500 value is 500 is lies between in this interval. Exactly the value of X is 500. So we replace X by 500. So 500 by 400 minus 1 by 2. So F of 500 value is okay. Next symbol is minus. So minus of. Now we find the value of F of 300. You see X value here 300. 300 is also lies in this interval. Okay. So we replace X by 300 here. So 300 by 400. Okay, minus 1 by 2. You see some terms are cancelled here. Is it possible? 2020 is cancelled. Here also 2020 is cancelled. What is the remaining of that one? 5 by 4 minus 1 by 2. I multiply minus inside. So minus 3 by 4. Minus of minus 1 by 2 is a plus 1 by 2. Minus of plus of is cancelled here. Remaining is 5 by 4 minus 3 by 4. 5 by 4 minus 3 by 4. 4 is a common. I simplify here. The remaining is 5 by 4 minus 3 by 4. The answer is 2 by 4. Okay. 5 minus 3 is 2 by 4. One more cancel is possible. So the answer is 1 by 2. Therefore, P of 300 less than or is equal to X less than or is equal to 500 value is just off. Is 1 by 2. All the values are in fraction, so no problem, we write in fraction. Density function f of x is a 2 value k into e power minus x by 3 when x is greater than 0. And x is less than or is equal to 0. Here we have just two cases. When x is greater than 0, that value. When x is 0 or less than 0, f of x value is defined as 0. Then there will be 5 subdivisions here. First, as usual, find the value of k. Next one, the distribution function. The another name of the distribution function is cumulative distribution function. 3, 4 and 5. We find some probability values. P of means probability of. To find all values, first we write f of x is a probability density function. First we write the word since f of x is a probability density function. What is the reason to write this line? Because we write this line, our integral value should be is equal to 1. F of x is a probability density function, only there will be a chance minus infinity to plus infinity f of x dx is 1. Is a formula. But the limit, lower limit and upper limit is changes depending upon our given problem. You see here f of x is possible only when the value of x is greater than 0. We already tell in continuous random variable greater than also is equal to greater than or is equal to. So f of x is possible only when 0 and some positive value. So how to write the given integral? For understanding I split it 2 minus infinity to 0 f of x dx plus 0 to plus infinity f of x dx. The single integration became a double integration for our understanding. Minus infinity to plus infinity I split, minus infinity to 0 and 0 to infinity. Now you see in this interval, f of x is a minus infinity to 0. That means the value of x is supposed to start from minus infinity. Minus infinity means some negative value. it has some negative value, f of x is defined as 0. So minus infinity to 0, in this interval f of x value is 0 plus 0 to infinity when x is greater than 0. Not only consider x is greater than 0. Greater than 0 means some positive value. 0, then the positive value start from 1, 2, 3, etc. up to infinity. In this interval f of x is defined as k e power minus x by 3 and dx is equal to 1. We cancel here because this is 0. In the second integration, k is constant. I will take outside the constant. 0 to infinity e power minus x by 3 into dx. So k of, what is the integration of e power minus x by 3? First of all, the integration of e power x is just e power x. Suppose if it is e power minus x by 3 is a composite function, the integration of e power is always first of all same. But is a composite function, again, we differentiate the power term with respect to x. What is the power? Minus x by 3. The differentiating of minus x by 3 with respect to x is minus 1 by 3. Important the integration. We put the value in denominator. Next we apply the limits. 0, infinity is equal to 1. This is a minus 1 by 3. This 3 is lies in denominator. So suppose it goes to numerator, it becomes just a 3. So minus 1 by 3. So minus 3k I write. Okay. Minus 3k. I will take outside. E power minus x by 3 of 0 to infinity is equal to 1. Now we apply the limits. Outside is minus 3k. What is the upper limit? Infinity. Infinity by any number is always infinity. So e power minus infinity minus the lower limit 0. So e power minus 0 by 3 is also minus 0. So minus 0 or plus 0. So minus 3k of 0 minus e power 0 is equal to 1. I write the value of e power minus infinity is 0. This is one formula. E power minus infinity value is always 0. E power minus 0 or plus 0, both are same. You know very well what is the value of e power 0? That value is 1. So minus and minus is plus. 3k is equal to 1. So the value of a k is 1 by 3. So first subdivision is over. To find the value of a k, the value of k is 1 by 3. Now to find the second subdivision, the distribution function. The another name of the distribution function is a cumulative distribution function. So we write the symbol also here. For understanding, I write the symbol also to find f of capital F of x. First we write the formula. Capital letter f of x. Formula is minus infinity to x f of x dx. What is the reason to use this formula? This x lies in a continuous random variable, so using this formula. Here also some cases. Yeah, okay. Small f of x is defined as two value when x is less than 0, when x is greater than 0. So to tell the two cases, the first case is when x is less than 0. When x is less than 0, that is one negative value. Suppose when x is a negative value, f of x defined as 0. So we write a formula minus infinity to x f of x into dx. Same, minus infinity to x. But in this interval, our f of x value is 0 because x is less than 0. So f of x is 0. So capital letter f of x value is 0. You know very well the least value is always 0. So first case is over. What is the second case? So case 1 is over. The second case is opposite of that one. When x is greater than or is equal to 0. For understanding, I will take the real line interval. Minus infinity to plus infinity. You know very well exactly the middle 0 is there. Now we will take the value of x is greater than or is equal to 0, more than 0. Suppose I will take x here. We find capital letter f of x. Its formula is always start from minus infinity up to x. Minus infinity to x, f of x dx. We need up to minus infinity to x. But minus infinity to x, you see there will be two intervals. It's a minus infinity to 0 and 0 to x. So minus infinity to 0 f of x dx plus 0 to x. Okay, then 0 to x f of x dx. I say in this interval f of x value is 0. Okay, when x is less than 0, f of x value is 0, so it's 0. But when the value of x lies in this place, then x is more than 0, so f of x is defined as k into e power minus x by 3. We already find the value of k also, so to substitute here to find the value of a capital letter f of x. Now we continue. In this interval f of x value is 0 and in this interval value is k into e power minus x by 3. So we leave. The value of k is 1 by 3. So 1 by 3 will be take outside 0 to x e power minus x by 3 into dx. So 1 by 3. We already see the integration of e power minus x by 3. E power minus x by 3 by minus 1 by 3 and the limit is 0 to x. I cancel this 1 by 3, 1 by 3, okay? It lies in numerator, it lies in denominator. The remaining is 1 minus 1 is also very important. So minus e power minus x by 3 to the limit 0 to x. First we apply the upper limit is x. Here also some x. So the upper limit value is minus e power minus x by 3. It lies in same. Next we substitute the lower limit with the minus sign. Already one minus sign is there. So minus into minus is plus e power minus 0 by 3. Understanding, I write elaborate. So minus e power minus x by 3 plus I say the full value is 1 because e power minus 0 by 3 is minus 0 or plus 0. E power 0 value is 1. So in this case capital letter f of x value is, first I write the positive value 1 minus e power minus x by 3. So it is a value of f of x in this interval. Therefore, the value of capital F of x has a two value. One value is 0 for or when x is less than 0. When x is greater than or is equal to 0, f of x has another value. The another value is 1 minus e power minus x by 3 when x is greater than or is equal to 0. So to find the second one is also over, that is to find the cumulative distribution function. But we find some probability value also. So that's why I keep the question. You see the third submission. P of x is less than 3. P of x is less than 3. P of 5 less than or is equal to x to find all value. First we find this P of x is less than 3. I write less than 3 is also less than or is equal to 3 because x falls in a continuous random variable. We already tell less than or is equal to is nothing but less than or is equal to. So what is the reason, sir, why we write here? Because we have only capital F of x. The formula of capital F of x is P of capital X is less than or is equal to small letter x. So how to write P of x is less than or is equal to 3? That value is just f of 3. That value is f of 3. You see 3. 3 is a number greater than 0. When x is greater than or is equal to 0, f of x is defined as 1 minus e power minus x by 3. But we need exactly f of 3. So we replace x by 3 in f of x. So that value is 1 minus e power, if x is there, minus x by 3. 3 is there, minus 3 by 3. So the value is, the value of f of 3, 1 minus e power minus 3 by 3. 1 minus e power minus 1. 1 minus e power minus 1. We leave as it is. Or we write it is 1 minus e inverse. We write 1 by e also. So the value of p of x is less than 3 is 1 minus e power minus 1. Now the fourth subdivision. The fourth subdivision is p of 5 is less than or is equal to x. P of 5 is less than or is equal to x. I write this word as p of x is greater than or is equal to 5. You write in this manner also. Okay. 5 less than or is equal to x, or x is greater than or equal to 5. Both are same. But x is greater than or is equal to 5 means here x value it may be 5 or it's not a discrete random variable. Suppose if it is discrete, it is ended to 6 7 like this. But it is a continuous random variable. The value of x is more than 5 means it goes up to plus infinity. So we can't find each and every individual probability value. So using capital F of x, so I use one formula. 1 minus p of x is less than a. I use the formula here. Because the minus sign suppose that side plus. Total probability is always 1. To find all probability value when x is greater than or equal to a, whose inverse is. To find all probability value when x is less than a. All probability value is 1, so the plus becomes that side minus. So how to write p of x is greater than or equal to 5? Using the same concept. In place of a here, 5. 1 minus p of x is less than 5. Now we use the concept of, now we use the formula here. We use the symbol is less than here. Next, for your formula understand, I write this less than as less than or is equal, because x follows continuous. What is the reason sir less than or equal to we use? We already have the formula of capital F of x. P of capital X is less than or is equal to small x. 1 minus. Now I write it is f of 5, okay? P of x is less than or is equal to 5. I write it is f of 5. Now what is the value of f of 5? You see the number is 5. The value of 5 is greater than 0. When x is greater than 0, f of x defined as 1 minus e power minus x by 3. So the value of f of 5 is 1 minus. Now the value of f of 5, you replace x by 5, so 1 minus e power minus 5 by 3. 1, I multiply minus inside, minus 1 plus e power minus 5 by 3. I cancel plus 1 and minus 1. So p of x is greater than or is equal to 5. That value is just e power minus 5 by 3. E power minus 5 by 3. Next, to find the fifth subdivision also, the fifth subdivision is p of x is less than or is equal to 4. Is a direct sum. How to write p of x is less than or is equal to 4? We write p of x is less than or is equal to 4 is capital letter f of 4, okay? Symbol of capital F of x. P of capital X less than or is equal to small x. So we write that one as f of 4. You see the value is 4. The number 4 is greater than 0. When x is greater than 0, f of x is defined as in this manner. So when you replace x by 4 here, so f of 4 is 1 minus e power minus 4 by 3. 1 minus e power minus 4 by 3 is the value of this probability. So the probability using the symbol is very important here, because it is a continuous random variable. X can take infinite number of values. Therefore using this property to find all probability values.